Okay, so I am going over how to prove triangles similar by using special triangle congruence theorems. I hope you watch this video and take notes because I am not here today to give them to you. It will help you with the worksheet that you also received today. So, our essential question is how can we prove two triangles are similar by using their corresponding angles and sides? There you go. So the first similarity theorem we have is angle-angle similarity theorem. So if two angles of one triangle are congruent to two angles of another triangle, so notice on this one, angle A is congruent to angle D, and angle B is congruent to angle E, then the two triangles are similar. Because remember we learned about the third angle theorem last semester, it's going to make C and F also have to be the same. So since all the angles are the same, all the side lengths are similar. This is the one we couldn't use for triangle congruence. It now works for triangle similarity. So I just wrote down, if angle A is congruent to angle D and angle B is congruent to angle E, then the two triangles, that little squiggly mark, means similar. So I have an example here. It wants me to decide if these two triangles are similar. If they are, I need to write the similarity statement, and I need to explain my reasoning. So it gives me two triangles. They both have right angles, and then it gives me two different angle measures. It gives me 26 and 64. So what I want to do is I want to take, because I know right here is 90 degrees. I want to take, the remaining angles in the triangle are 90 degrees. So I'm going to take 90 minus 26, which gets me 64 for this angle right here. So because these two angles are the same, sorry, I'm not very good at drawing with the pen on the screen. Because these two angles are the same, the two triangles are going to be the same. So to write my similarity statement, I write the triangle symbol, and then I go with my matching angles. So I'm going to just label my first triangle however I want, CDE, and I'm going to have is similar. The 26 degree angle was right here at K, so then I have to match up. So C was 26, so K is 26. Then I went to my 90 degree, which on this triangle is G, and then I went to my 64, which is H. And this is by AA similarity. Okay, these ones want me to show that they're similar. So I have angle A is congruent to angle A for both triangles, because I have this giant one, and then I don't know how to change my pen color, so I'm just going to draw it up here. Then I have A, E, B. So that's congruent by reflexive. And then I have angle B is congruent to angle C by definition of congruent. And then the two triangles are similar, A, B, E, similar to triangle ACD by AA. Over here, I have angle SVR is congruent to angle UVT, and this is by vertical angles. Okay. Then I have angle R is congruent to angle T, and this is by alternate interior. So then the two triangles, that's a triangle symbol, I'm sorry, SVR is congruent to triangle UVT by AA. Next we have the side-side-side triangle similarity theorem. So this is if the corresponding side lengths of all three sets of sides have to be congruent, then the two triangles are two sets of sides have to be proportional, then the two triangles are similar. So here it's just written out, if So if the side length AB is similar to the side length RS, then it has to also equal BC and ST, that ratio. And then CA and RS, that ratio has to be the same. No, not what I meant to do. So here's an example. It wants me to figure out if any of the triangles are similar to ABC. So this one's really nice because it has it color-coded, so I know which sides match up. So I'm going to do, this is going to be my old, and this is going to be my new, and this is going to be new too when I do it second, because I have to do it twice. So I'm going to do 6 to 8 for my red sides. That gives me 3 over 4. And then I'm going to do 12 to 16. If I divide those both by 4, I get 3 over 4 again. Then I have 9 over 12, which also gives me 3 over 4. So I have that triangle ABC is similar to triangle DEF. And now I need to go check to see if it's similar to GHJ. So I have 8 to 8 for my red sides, which gives me 1. Then I have, for my blue sides, I have 16 to 16, which also gives me 1. Then my green sides, I have 10 over 12, which gives me 5, 6. Not the same, so this one is not similar. On this example, it wants me to find the value that makes the two triangles similar. So I have 4 and 12. I'll just say this one's my old and this one is my new. So I'm going to have 12 over 4 for my first inequality. Then I'm going to have this side, I'm going to make it with a box since I don't know how to change my pen color. So I'm going to have 18 over x minus 1. I could use this bottom side, but then I'd have 2 x's in the equation and it would make it a little bit harder. So I'm going to pick the side with just one set. So I want to cross multiply. Then I have 12 times x minus 1 equals, over here, I have 4 times 18. 18. On my left side, I want to distribute. I have 12x minus 12. On my right side, I don't know what 4 times 18 is, so let me grab my calculator. 4 times 18 gives me 72. Then I want to add 12 to both sides. I have 12x equals 84. I divide both sides by 12. That is an ugly one. And I get x equals 7. There's a third and final theorem that I can use to prove triangles are similar. It's the side angle side similarity theorem. So if the two sets of sides are similar and the angle in between them is the same, then the two triangles are similar. So here is words of what I just said. I'll give you a few minutes to copy this down. Okay, and then I believe I have the similarity statement. Yeah. So if the two angles, x and m, are congruent, and then the sides surrounding them, so I have zx and mp, those are congruent. That's not my erase button, not my erase button. And then I have xy and mn are congruent, then the two, similar, proportional, then I have the two triangles are congruent. Similar, sorry. Okay. So this one is telling me I am building a lean-to shelter, and it's like on a hill, so it's not exactly straight, but I want to construct it so that my right end is similar to the left end and using the angle measure so. So we want to see if this picture is set up correctly. So I have the first step right, I have my angle is the same, So then I'm going to just say this one is old and this one is new. I'm going to take my new side, which is 9, over my old side, which is 6. Gives me 3 halves for the up and down sides. Then I'm going to do the same thing with 15 to 10. I divide by 5 on both. I get 3 halves. So this is yes by side angle side similarity.